Hi, so we want to consider finding the roots of a quadratic equation. So for the left-hand side, we are looking at using the quadratic formula. The quadratic formula, of course, looks like this: x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now for this, it's important to know what a, b, and c are, so that you will be able to use the quadratic formula properly. So what you need to do is to compare your equation with the general form of a quadratic equation, which is ax squared plus bx plus c equals to 0. Now if you compare, you will see that your a will be 1, because that will just be ax squared right there. So a equals 1, and you see your b is negative 4, and your c equals to 4. Next, we input that into the formula, and then you have x equals to negative b, which is negative 4, plus or minus the square root of b squared, which is negative 4 all squared, minus 4 times a, which is 1, and times c, which is 4, all over 2 times a, which is 1. And then all we need to do is to simplify this further. So you have 4 plus or minus the root of, you've got 16 right there, minus 16, and that gives you 0. Okay, all over 2. Okay, and this gives you 4 over 2, which gives you 2. So x equals to 2 twice. Okay, the second method is using the complexity square to solve this. Well, what's peculiar about this question is that it's already a squared, so we wouldn't need to do much about it. So I already know this is a square, because if I rewrite this as x squared minus 4x, this 4 here can be written, of course, as 2 to the power of 2 equals to 0. Now, a square always takes this form. How do I know? If I look at the coefficient of x squared here, it is minus 4. If I take half of that and then I square it, I will actually have negative 2 all squared, which is the same thing as 4. And that's exactly what is here. All I just need to do now is to rewrite this as negative 2 all squared. That's all I needed to do, okay? And it's exactly what a square will look like. Now that I know that it's a square, I just need to rewrite it as such. So I have x minus 2 all squared equals to 0. Take note that if you expand this, you get back the original question. It's very important to go through this so that you know that nothing is missing and you have not done anything wrong. Okay, so now I have that. All I just need to do is to take the square root of both sides, so that I have x minus 2 equals to the square root of 0, which is also equal to 0. And then I have x equals to 2. Okay, now I've got both my methods right. All I need to do now is to sketch the graph, because I need sketching of the graph to be able to explain exactly what I'm trying to do here. Okay, so if I'm to sketch this graph, there are a couple of things I need. I need the y-intercept. So the y-intercept is 4. I also have a video on the sketching of quadratic graphs, so please link it up. You want to go look at that. It's very, very informative. You learn a lot. The y-intercept equals 4, because that's just this guy here. You just want to pick it out. No fuss. Then the next thing I have will be the minimum of the graph. So the minimum, you pick it out from this form. Okay, so the minimum, you pick the negative of this, which is 2, and then the y value is actually 0, because this form is always written as this plus something, and you see that it's 0 that is there. Okay, that form is always written as x plus maybe b all squared, then plus h equals to 0. The h there is 0. Okay, it's 0 because you can't see any other letter there, any other number. basically. So what is there is 0. So again, to pick the minimum, all you just need to do is to consider this form. And you see that what is there is x minus 2 all squared, then plus 0 equals to 0. I'm writing it that way so that you see that, the y value of the minimum is 0. All right. Again, there's a video on that. I'll link it up so you just check that out so that you have a full knowledge of what that is all about. So the minimum is 2, 0, which I've written down. I have the y-intercepts now. The other thing we need is the roots. And we already solved for x. So we know that the roots is 2. X equals to 2. Okay, twice, don't forget. X equals to 2 twice. It just means that the x-axis acts as a tangent to the curve at the point x equals to 2. When we start sketching, you will see what I mean. So let's go ahead and sketch this graph. A number of things. We know that x equals to 2, so I'm just going to mark that as x equals to 2. We also know that the y-intercept is at 4, so I'm going to mark that as 4. Okay, and I think I have all I need. I've got the y-intercept to be 4. I've got the minimum done. So you will notice that the minimum is exactly at the roots. That's that point there when x is 2, y is 0. So the minimum is also at the point where we have the roots. So to sketch this, our graph will look like this. Okay, so this graph is already sketched. So you can see what we have right there. So you will notice that the x-axis serves as a tangent to the curve at this point. What does that mean? This brings me to explain what the discriminant is for the quadratic equation. Okay, now I need to explain what the discriminant is. You remember that we use the formula x equals to minus b plus or minus square roots b squared minus 4ac over 2a. Okay, now the discriminant just helps us to separate the different types of quadratic equations that we might have. Now, some quadratic equations we obviously have no real solutions, while some will have equal solutions, equal real solutions, and while some will have distinct solutions. Now, this is very important. This knowledge is very important because questions from your examination will come, from this part of learning about quadratic equations. Okay, so the discriminant is very important. Now, what is the discriminant? This part here under the square root is the discriminant. And the reason is because it helps us to distinguish between the different type of quadratic equations that we might have. Let's take a look at this particular example that we've just finished. We know that x squared minus 4x plus 4 equals to 0 is the equation that was sketched here and that we have solved earlier. Now, if you notice, what we had under the square root gave us 0, okay? So if we do b squared minus 4ac, from this equation, we have b squared to be negative 4 all squared minus 4 times a, which is 1, and c, which is 4. And then from this, we have 16 minus 16, which gives us 0. Okay, so anytime whatever you have under the square root here gives you 0, it just tells you that you're going to have real and equal roots. And that's because if this is 0, this plus or minus becomes useless. It just becomes something that we have to do away with. So if we do away with that, it simply means that the value of your x will always be minus b over 2a when the discriminant is 0. Okay, and that gives you just a single root. And because it's a quadratic equation, you should be having 2 roots. And that tells you, okay, that you have real and equal roots. All right. And the key thing to also note here is this. If you have real and equal roots, it means that the x-axis will serve as a tangent for the curve. This is very important, okay? Anytime b squared minus 4ac equals to 0, note that you have real and equal roots, okay? And then also note that the x-axis serves as a tangent. Serves as a tangent to your curve. For this second example, we are going to look at how to use a quadratic formula for this particular equation. We know that the first thing we want to do is to compare this equation with the general form of a quadratic equation, which is ax squared plus bx plus c equals to 0. So with a casual look, you'll be able to see that a here will be 2, b will be minus 3, and c will be negative 35. Remember that the formula is x equals to minus b plus or minus square roots of b squared minus 4ac all over 2a. And all we just need to do now is to substitute. So we have x to be equal to minus 3 and plus or minus b squared, which is 9, minus 4ac, which I think will be minus 4 times 2 and then times minus 35 all over 2a. Okay, so 2a there will be 2 times 2, which will be 4. So a quick use of our calculator will give us 3 plus or minus root of 289 over 4. Okay, the root of 289 is 17, so we have 3 plus or minus 17 over 4, which will give us 3 plus 17 is 20, 20 divided by 4 is 5, or 3 minus 17, that's minus 14 over 4, which is minus 7 over 2. Next, we use the method of completing the square, and I'm just going to get right at it. The first thing I want to do is to factor out 2. So I'll bring out 2, and then in brackets I will have x squared minus 3 over 2x minus 35 over 2 equals to 0. Okay, the value in the brackets, if you like, you want to complete the square, you get x squared minus 3 over 2x, and you get plus minus 3 over 4 all squared. If you want to know how I got that, it's another video that I've made on completing the square. Please go on and watch it now. You will find the link up there. Okay, so I'm going to subtract 9 over 16 because obviously this wasn't there before. I just brought it out. And by subtracting it, it ensures that I've really not added anything, so that I've not messed up with the balance of this equation. Okay, so 35 over 2 close the brackets equals to 0. All right, now this first trinomial right there can be written as x minus 3 over 4 all squared. Okay, and then the other part can be written as minus 16 as the base. Okay, and then you have 9 plus 280. Okay, equals to 0. And this will give me 2 into x minus 3 over 4 all squared minus 289 over 16. Okay, equals to 0. If I distribute 2, I get 2 into x minus 3 over 4 all squared minus 289 over 8 equals to 0. All right. Now, the form is that it's very, very good because it tells me what the minimum will be if I intend to sketch this graph. So I can pick the minimum easily. Minimum will be at 3 over 4 and at negative 289 over 8. Now, negative 289 over 8 is negative 36.125. So let me just write that as negative 36.125. And 3 over 4, of course, is 0.75. So let me just write that down. 0.75. Okay, that's the minimum. All right. Now I go back to solving for x. I'll take this negative to the other side. So if I do that and I divide both sides by 2, I will have x minus 3 over 4 all squared to be equal to 289 over 16. All right. So, and you know, everything else generally follows from using the quadratic formula, because of course the quadratic formula was derived from complexity square. I also have a video to show the derivation. If you want that, please click it now. The link is up there and then you can watch. Okay, so you will find that your x will also be equal to 5 or negative 3.5 if you like. Okay. Now that we have found the solutions from both methods, we are left to sketch the graph. We know the minimum already. Now, can we pick out the y-intercept? We know the y-intercept will be at negative 35, because all you just need to do is to make x 0 anyway, because you know anyway your curve crosses the y-axis, x will be 0. If you make x 0, it cancels this first 2, and then you're left with negative 35. And then we know the roots to be at 5 or negative 3.5. So I'm just going to label that 5, negative 3.5 is just a sketch, so we are not going to be accurate. Okay. The minimum, of course, will be at negative, so at 0.5, we could put the minimum somewhere here. Okay, we could put it somewhere here. And of course, the y-intercept will be at 15. So that will be where the graph crosses the y-intercept. So we could put 15 here if you like. We'll put 15 there, or the y-intercept is negative 35. So we could put that here if you like. That's negative 35. And then of course this will be the minimum, which will be negative 0.75 and negative 36.125. Okay, and then we can sketch our curve. Okay, and the curve is sketched. All right. Remember that in the previous example, when we had b squared minus 4ac to be equals to 0, what we had was 2 equal roots. Now, in this particular example, we notice that the discriminant, which is b squared minus 4ac equals to 289. Okay, and because of that, we had two distinct roots. And the two roots were, they're right here, 5 and negative 3.5, two distinct roots. Which means that anytime you have your b squared minus 4ac to be positive, okay, not equal to 0 this time, this is a positive number. So anytime we have it to be greater than 0, which means positivity. If it's greater than 0, it is positive. So when we have it to be positive, we expect to have two distinct roots. So that is the second scenario for our discriminant. Remember, the first one is when it's equal to 0, we have two equal roots. And I mentioned that at those times, okay, when you have two equal roots, the x-axis serves as a tangent. Remember that. X-axis serves as a tangent. X-axis serves as a tangent to the curve. Okay, for this one that is not the case, we just know that you have your curve and then the x-axis will be crossing it like so. You can see the x-axis crossing it. The one in the previous example just touched the x-axis and went back up. Okay, touched it. There's no daylight between the x-axis and the curve. For this one, Okay, it is crossing it. So this is what we have. We have two distinct roots. Now, there will be a third one in the next example, and that is when we have our b squared minus 4ac to be less than 0. Let's go to the next example. Okay, for the third example, let's take a look at x squared minus 4x plus 5 equals 0. To use the quadratic formula, remember that we have to compare it with ax squared plus bx plus c to be equal to 0. And then we pick out a to be equal to 1 because that's the coefficient of x squared here. Remember that a is the coefficient of x squared here. So if you compare with this one, you see that a is 1. All right. In that sense, we know that b will be negative 4. We can see it here. And then we know that c will be equal to 5. Now, what we need to do is to use the formula x equals to minus b plus or minus root of b squared minus 4ac over 2a. All right, so we have minus b is minus 4 plus or minus square root b squared will be 16 because that's minus 4 squared. So you have minus 4 times a, which is 1, and times c, which is 5. Okay, all over 2a, which will be 2 times 1, and that is 2. If we simplify this further, we have 4 plus or minus 16 minus 20, that's minus 4 square root, okay, over 2. All right, and as you can see, this cannot be solved. Okay, so it means that there will be no point using the completing the square method because we know that there will be no solution. However, we might want to learn more about this particular equation by sketching the graph of x squared minus 4x plus 5 equals to y. So instead of saying equals to 0, let's say equal to y. And then we could try and look at, completing the square here and then, sketching this particular curve. If we do that, okay, we might then understand this one better and why there is no solution. All right. So I'm going to try to complete the square from this end and then use some of those things we have learned to sketch the graph. So complete the square, we are going to have, this is already x squared there. So I have x squared minus 4x, and then I want to add minus 2 all squared. If you need some explanation about what I'm doing, there is a video that has more explanation and more examples on it. I'm linking it up right now. You want to check that out. So x squared minus 4x plus that, then I want to subtract 4 so that this cancels out essentially. And then we have this, okay? Then plus 5 equal to y. All right, now this trinomial then becomes x minus 2 all squared. And then minus 4 plus 5 will just give us plus 1 equal to y. So writing it this way helps us to choose our minimum. So the minimum for this graph, that's the lowest point, is at 2 and 1. So normally you just take the negative of that and then you take that the way it is for the y. So minimum is 2, 1. We know the y-intercept is easily seen, okay, from the original equation. So the y-intercept is going to be at 5. Okay, so y equals to 5, that's the y-intercept. It's just right there. All you just need to do is to make x to be equal to 0. If x is 0, the first two cancels. And then you've got 5. Okay, for the x-intercepts, or the roots, remember that the x-intercept or the roots, this one does not exist, so it's not applicable. Okay. I think with this one, we should be able to sketch our graph. We know the minimum point is at 2 and 1. So let's label this at 2. Okay, and label this as 1 if you like. So that'll be that. 2, 3, 4, 5. Okay, so that'll be 2, 1 right there. And we could label this if you want. This will be 2, 3, 4, 5. So label our 5. So we have what we need to sketch our graph, and if you do that, this is what you get. So I've tried to sketch it as best as I could. Okay, so this is what you notice, all right? This part that says it's equal to 0 here, they normally it should be y. So they're asking you to find where this curve, which is naturally this one, okay, where that curve will meet with y equals to 0, okay? And this is y equals to 0. The x-axis is always the line y equals to 0. And you can see that they don't meet. So literally, this one floats, all right? And because it doesn't meet, that's why you don't have a solution. I hope the graph will, makes it much more interesting, because you can see why this particular equation has got no solution. All right, so just one more thing to discuss, and that is the role of the discriminant. So for this particular one, notice that what we had under the radical here is negative. So let's go ahead and complete what we have here for the discriminant. Okay, this will not be the graph for this one, so I'm just going to clear it out. All right, so to finish this, we just put this as the last point, and then we say that if our b squared minus 4ac is negative, just as like the last example, that is, it's less than 0. If that is less than 0, we have no real roots. No real roots. No real roots. All right, so remember the discriminant is the quantity b squared minus 4ac. And this helps us to discriminate between all the types of quadratic equations that we might have. The ones that have got 2 equal roots, the ones that have got 2 distinct roots, the ones that have got no real roots. Okay, so I hope this series of examples have helped you to understand what the discriminant is, and also to understand how to use the formula to solve a quadratic equation. It's also try to show you how to use the method of completing the square for each of these examples. So this video, I think, has been quite good, quite informative, and I hope to see you in the next one. Bye.